Okay, here's the woman. The man, 10 meters apart, and if you fix the origin at where the woman is, she is zero distance away. So when you use that formula, that becomes zero. You get it as 6.15 meter. Not a big deal. Now B, the ratio of the distances that they move will be in the inverse ratio of their masses. So the woman would move 3.1 when the man moves 2, so both of them together move 5.1. So what's the distance between them now? 10 minus 5.1. Now the C part, they have to collide at the center of mass, which is 6.1 meter away from the lady. So how much does the man move? 10 minus 6.1, and the woman would move 6.1, of course. Together they move 10 meter. This is a question that was done in class, and you got to remember that the ball is returning. The ball is going in the opposite direction. You have to be aware of all these quantities in physics, and you have to be really careful. It's just a matter of putting the formulas together for impulse and finding the force. This was a question again that was done in class. Find the velocity with which it reaches the floor, and then find the velocity with which it begins to go back up, using the conservation of energy in both cases. And when something that was done in class is repeated on the exam and you find it difficult to do it, this means that work is not being done. So got to be careful about that. Now this was surely a problem that everybody should have got. The velocity with which it comes down and the velocity with which it goes up. You have both, so find the change in momentum which gives you the impulse. Remembering that it's going back in the opposite direction again. And here your angular momentum is I omega, and the momentum of inertia mass squared by 2. Omega is 2 pi f, which is the frequency, which is the number of rotations in 1 second. Find that first and then plug it back into this. That gives you the angular momentum as 13.33. And to find the torque is just the change in angular momentum divided by the time. The rate of change of angular momentum, 2.67. Young's modulus, it is a pretty straightforward question. Got to remember that what's given is the ratio of the change in length to the original length times 100. So that's what you find there, 0.04 by 100. So when you calculate, you get the force, and then mass is force divided by the acceleration due to gravity. which is 57.70 kilogram. This was worked out in class, so I'm not going to waste any more time. Well, in this question, it's a particular case of conservation of angular momentum. So first find the moment of inertia of the disk. Find the angular velocity from the given frequency. And then find the the moment of inertia of the clay, piece of clay, chunk of clay, which says that it's shaped as a flat disk. So use the formula again. Find its moment of inertia. And now omega 2 is what you're trying to find out. So now I1 omega 1 is equal to I2 omega 2. In the second case, you have to add the moment of inertias of both of them. And that's how you get this number. When you do that, you get the angular velocity, but what's as the frequency? So you divide it by 2 pi to get the frequency as 1.36. Hertz. The pendulum swinging up, first you have to find the velocity with which it begins to move up using the conservation of momentum, linear momentum. This is an experiment that was done, a particular lab that was done. And all these calculations were done in the lab too. So you get it as 1.77 meter per second. So then use the conservation of energy and find the height. It is 0.16 meter. Now there are many ways to find x, but I'm using the formula that you used in the lab to find the angle. Once you get the angle from the right angle triangle, sine theta is x divided by the length, and so x is L sine theta, which gives you 2.8 sine 19.47, and so x is 0.933 meter. This, I think, was a question from Mastering Physics. First find theta, using tan theta is 2 by 2.6, and then you see that ft is resolved into two components, ft sine theta and ft cos theta, but you only need ft sine theta. So first find ft sine theta. Calculate that, you get 67.1 Newton. And then remember that that force, which we just calculated as 67.1, this one can again be resolved into two components. So one would be this, which is 67.1 cos 30 degrees, because it's a equilateral triangle here. So you get 67.1 cos 30 along this direction. You do the same here, so you get 2 times that. So that's why you have 2 times 67.1 cos 30 degrees, which gives you 116.24 Newton. Well, that's it. Hope you prepare for the final exam using all these. Good luck.